In today's question, A, B are positive values such that the sum equals to 100. We are asked to find the nearest integer of the maximum of this expression.
Pause the video now if you wish to solve it. Keep watching the video once ready.
Provide three different methods of doing this. Number one, using differentiation. Number two, using trigonometry. And number three, using AMG and inequality. Using differentiation, we will let y to be equals to x, let a equals to x, and a is x, b is 100 minus x. So for this case, x is in between 0 and 100. So now we are going to find what is the maximum of y here. dy dx equals to this expression, and it is equals to 1 minus. Next, in order to get a maximum of y, we should let dy dx equals to 0. It is equals to 0 if and only if x minus 50 over square root of x, 100 minus x equals to 1. And this will mean that x will be equals to 50 plus 25 square root of 2. We should verify that this value of x will make y to get a maximum value. So we need to check d2y dx2. Okay? So if we differentiate dy dx once more, we get d2y dx2, and after long calculation and manipulation, we'll get that this is negative 2500 over x, 100 minus x to the power of 3 over 2, which means that this is always negative. Since d2y dx2 is always negative, we conclude that y indeed is maximum at x equals to this value. Y maximum will occur at when x equals to this, so this will be 50 plus 25 square root of 2 plus this is 50 plus 25 square root of 2, 50 minus 25 square root of 2. This will equal to 50 square minus 25 square times 2. So be equals to 2. So this is 20 plus 20 square root of 2. And this is approximate to 120.71. So the nearest integer for this 120.71 would be equals to 121. Okay, so this is the approach from using differentiation. The next approaches, we are going to use trigonometry. As the sum of a and b equals to 100, I may let a equals to 100 sine square and b equals to 100 cosine square, theta in between 0 and pi over 2. So a plus square root of ab is therefore equals to 100 sine square plus square root of ab will be equal to square root of 100 square sine square cosine square, and it gives you 100 sine theta cosine theta as theta in the first quadrant. So this will be equal to 50. This is 2 sine square plus this is 2 sine cos. 2 sine theta cos theta equals to sine 2 theta. And for this will be equal to 1 minus cosine 2 theta. From here we have sine 2 theta minus cosine 2 theta. If I are going to use our formula, then this will be equals to 1 plus square root 2 sine 2 theta minus pi over 4. And because sine is not more than 1, this expression will be not more than 50, 1 plus square root of 2. Equality holds if and only if 2 theta equals to pi over 4. Theta equals to pi over 8. So therefore, equality holds if and only if a equals to 100 sine square pi over 8. In this case, we'll get the same answer as a method of using differentiation. The next approach is by AMGM. It is more interesting. Okay. So since a plus b equals to 100, we may multiply both sides by half square root 2 plus 1. Half square root 2 plus 1. And this is equal to 50 square root 2 plus 1. By AMGM inequality, half square root 2 minus 1a plus half square root 2 plus 1b will be greater than equals to 2 and square root of half of square root 2 minus 1a and half of square root 2 plus 1b. This is half square. We can take it out and cancel with the 2. The product of square root 2 minus 1 and square root 2 plus 1 will give you 1. And therefore, this is equals to square root of ab. Then a plus half square root of 2 minus 1a plus half of square root 2 plus. This is greater than equals to square root of ab. We plus a at both sides. This expression will give you half square root 2 plus 1a, and for b you have the same coefficient. So this is exactly what we have. And we already know from here that this is equals to 50 square root 2 plus 1. And therefore, it means that a plus square root ab less than or equals to 50 square root 2 plus 1. The equality holds if and only if half square root 2 minus 1a equals to half square root 2 plus 1b. And having solved all this, we will know that a will be equals to 50 plus 25 square root 2 and b equals to 50 minus 25 square root 2, which means that this value is achievable, and therefore this is the maximum value for a plus square root of ab. And this is end of the AMGM inequality method.